Dear students, in this video I am explaining Cauchy's integral formula. The statement of this Cauchy's integral formula is if f of z is analytic inside and on a simple closed curve C, and if A is any point within C, then f of A is equal to 1 upon 2 pi I integration of C f of z divided by z minus A into dz. In the statement we have the 3 points. F of z is analytic inside and on a simple closed curve C, and if A is any point within C, then we have f of A is equal to 1 upon 2 pi I integration of C f of z divided by z minus A into dz. The proof of this Cauchy integral formula is, let us consider the statements given. Since A is point within a C, we shall enclose it by a circle C1 with Z is equal to A as a center and R as a radius, such that C1 lies entirely within C. You can observe here that let us consider the x and y axis. A is any point within a C. So let us take one curve, that is the curve C. In this curve, A is any point within a C. Let us encircle it by C1 with Z is equal to A as a center and R as the radius, so that C1 is lying entirely within a C. The function f of z divided by z minus A is analytic inside and on the boundary of the annular region between C and C1. According to the previous property, integration of C f of z divided by z minus A into dz is equal to integration of C1 f of z divided by z minus A into dz. Call it as equation number 1. The equation of C1, that is circle with center A and radius R, can be written in the form of modulus of z minus A is equal to R. This expression is also equivalent to z minus A is equal to R e raised to I theta, or we can write it as only z is equal to A plus R e raised to I theta, where theta lies between 0 to 2 pi. Now differentiating this with respect to z. So z differentiation is 1 is equal to derivative of A with respect to z is 0. R is constant, will keep as it is. Derivative of e raised to I theta is e raised to I theta into I. Again derivative of theta is d theta by dz. So dz is shifted to left hand side. Therefore dz is equal to I r e raised to I theta into d theta. Using these results in the RHS of equation 1. So we have integration of C f of z divided by z minus A into dz as it is, where the curve is lying, theta is lying 0 to 2 pi. Therefore we will take the limits theta is equal to 0 to 2 pi. F of z is there, but we will take the z value A plus R e raised to I theta into dz. Dz value is I r e raised to I theta d theta divided by z minus A is there. Z value is A plus R e raised to I theta minus A. Plus A minus A will cancel, R e raised to I theta. And here R e raised to I theta and this R e raised to I theta will cancel. Therefore it is I into integration of theta is equal to 0 to 2 pi f of A plus R e raised to I theta into d theta. This is true for any r greater than 0. However, it is a small, so r tends to 0. Therefore, integration of C f of z divided by z minus A into dz is equal to I into integration from theta is equal to 0 to 2 pi. If r is tending to 0, then this entire term will become 0. Only will remain with f of A into d theta. The integration is with respect to theta, therefore I into f of A as it is. The integration of d theta is theta with the limits 0 to 2 pi. If we substitute the upper limit, it will become 2 pi minus lower limit is 0. Therefore it is 2 pi I into f of A. Therefore we can write f of A is equal to 1 upon 2 pi I integration of C f of z divided by z minus A into dz. This is the Cauchy integral formula. We also have the generalized Cauchy integral formula. If f of z is analytic inside and on a simple closed curve C, and if A is a point within a C, then f raised to n of A is equal to n factorial divided by 2 pi I integration of C f of z divided by z minus A raised to n plus 1 into dz.